fellow tech enthusiasts, welcome back to my channel, Errors to Earnings. Hi, I'm Divya and today we are going to discuss about traditional file-based system and its limitations. So while late, let's get started. So, what is traditional file-based system? You can say that a traditional file-based system is a way to store and manage data directly on operating system using files and folders. For example, think of a text file or an Excel sheet where we manually write, read and manage data. Sounds simple, right? But remember, simplicity comes with some major drawbacks, which we will explore shortly. Now, what is a database management system? So we have already learned what is a database management system, right? So it is a software which helps us to store, retrieve and manage data efficiently instead of relying on plain files. So it organizes data in form of tables and uses queries to access it, which ensures security and integrity, right? For example, tools like MySQL, PostgreSQL and Oracle DB allows us to manage huge amounts of data seamlessly while solving many of the limitations of file system. So let's get started into the limitations of file system. Alright. So let's understand the limitations of traditional file system using an example. So let's consider an university which stores its data in the form of files and folders. Alright. And let the folders be students, finances, academics, non-academics. Alright. In those folders, we have files like students.txt, hostel.txt, transport.txt, along with studentbalance.txt in finances, payment logs, courses.txt, attendance.txt, events.txt, and clubs.txt. We have a lot of files, but now let's understand with these examples. So, the first limitation is data redundancy and inconsistency. In traditional file systems, data is often duplicated across multiple files. For example, we can see that student ID and phone number have been repeated multiple times, even in the hostels.txt. Like student ID, we have again phone number in hostels.txt, right? So this is redundancy. Whereas DBMS makes sure that there is no redundant data using normalization. So now let's understand how inconsistency is maintained in traditional file system. Let's say there is a student with student ID, let's say 4001 something. Alright. And student name is, let's talk about X. And his phone number is, let's say 93 something. Alright. Now, and his grade is around 8.95. And he has a mentor, let's say the mentor is Dr. Y. Okay. Now, in hostels.txt, we store the student ID as same 40001 along with phone number 93 something something 1, and he is staying in the second block and his room number is 404. Alright. Now, the student wants to change his phone number. He wants to update his phone number. So, he updates his phone number. Let's say we have updated the phone number in students.txt. So he updated his phone number into 855 something. Alright. Now I forgot to update in the hostels.txt. Now what happens? There is inconsistency maintained. Alright. So this is the reason traditional file-based system have inconsistencies, whereas DBMS do not have any inconsistency. Now let's get into the next limitation. So that is difficulty in accessing the data. Alright. So what happens is accessing data in file-based system can be challenging. We often need to write custom programs to fetch the specific data, or we often need to do it manually. Let's say, for example, I want to find the student who takes the course Math 1001. Now what do I need to do? Suppose if it is an Excel sheet, I can use filtering. Suppose if it is a text file, I have to use manually, right? I have to do Control F and search for every student who is taking the course Math 1001. Now, what happens with DBMS? Simply we write a query. Select star from courses where course ID is equals to Math 1001. We automatically get all the students who have taken Math 1001, right? So DBMS makes very easy to access the data using queries. All right, so that is the reason why DBMS is better than the traditional file system. So now let's get into the third limitation, that is data integrity. So in file system, data is scattered across multiple files, making it hard to relate and retrieve. So what happens is maintaining data accuracy and consistency is harder in file systems. For instance, understand that we have grades.txt where we have information like student ID, his marks and his grade. All right. Now the total marks are usually summed around 100, right? So let's say I have entered the student ID as 1005 and his marks I have entered as 105 marks. So 105 marks is not possible, but in file system you can write as 105 marks, right? So here what happens is in DBMS we can write constraints. We can use constraints like check constraints which make sure that the marks are greater than or equals to 0 and less than or equals to 100. That means if I try to enter 105, it shows an error because a rule has to be followed here. A constraint and a rule has to be followed here. You got the point, right? So DBMS maintains the data integrity, whereas file system cannot maintain the data integrity. So the next limitation is atomicity problems. So what are the atomicity problems? For example, in file system, if a process fails in midway, you are left with partial updates, alright, which leads to data corruption. Now, let's consider the finances folder. We have two files in there, right? One is student balance and the other one is payment log. So in student balance, we have two students. Let's assume that we have two students, X and Y, and that balance at 30,000 and 20,000 respectively. Now, the student X decided to pay the amount. So he paid the amount. I have updated here. So now the balance would become 0 since he paid everything, right? So now, because of a power failure or system crash, I couldn't be able to update in the payment log. That means usually what happens is with some payment ID, let's say XXX, with some payment with student ID 1 and amount how much he has paid 30,000, right? And he has paid, let's say, on 27th of this month. So 27th of this month he has paid the amount. So I have to update in the payment log. But because of a failure, because of a system crash, I couldn't update in the payment log, right? So this leads to the atomicity problems. Since DBMS follows ACID properties, which we have discussed in the previous lecture, it makes sure that all operations are performed at a time. Either none of it takes place. That means it will update both in student balance as well as payment log at a time. You got the point, right? And next comes the limitation, concurrent access. So what is concurrent access? If concurrent access is nothing but two or more people trying to access the same file at a time, right? File systems generally struggle with concurrent access. If two users, let's say, try to update the same file simultaneously, it can lead to data corruption or data loss. Whereas DBMS handles this with isolation mechanism to ensure that transactions don't interfere with each other. Let's say, for example, consider this scenario. So we have taken the attendance.txt and there are two students, X and Y, and X has attended 10 classes whereas Y had attended 11 classes. Now, two users are trying to access. So let's consider this as user 1 and this as user 2. Alright. So let's say user 1 is process 1 and user 2 is process 2. Now, what happens to process 1? Process 1 adds extra one class to X. Alright. And X classes would become 11. Whereas process 2 will add extra one class to Y. So the classes becomes 12. Here, when process 2 is adding to Y, X classes would remain same. That is 10. When when process 1 is trying to add to when process 1 is trying to add to X, the process Y remains same. That is Y is equals to 10. So data loss and data corruption happens here. Since both read the same original file at a time and make changes, they overwrite each other's update. So what is the result will be? So one process's changes are lost and the database becomes the inconsistent. You got the point, right? And next comes the security problems. Generally, file-based systems rely on OS level security. which is often insufficient. Whereas DBMS, on the other hand, offers robust security features like user authentication, role based permissions, and encryption, which keeps the data safe. For example, let's say a student in the university got hold of all the files. What happens? He can change anything he wants. He can change his grade, he can change his CGPA, he can change his attendance, he can change his fee structure and all, right? But when it comes to DBMS, only admin has the access to change the things or update the things. So that is the reason DBMS provides good security when compared with traditional file-based system. So does that mean should we abandon file system completely? No, not necessarily. Traditional file systems can still be useful for some simple tasks like storing small documents or images or configuration files. But in case if you are dealing with large amounts of structured data or required features like security, scalability, integrity, transactions, consistency, accuracy, then DBMS is the way to go. Thank you all for joining in today's lecture. Don't forget to like, share and subscribe. Until next video, see you. Bye bye.